So look at something like this. If I have two congruent shapes here, and notice I don't actually have the shapes drawn, I just have their labels listed, but I can tell what kind of shapes they are because there's 4 values here. I would have to connect 4 points. And so I could just make up any 4 points here if I wanted to draw kind of a visual of this thing. And call it H-I-J-K. And then if I have a congruent shape to that, well, it means I would have to have another shape that's identical to that thing. And so I draw something that looks identical here. But now in terms of the labeling, because I started in this corner and worked my way around this way for the labeling, I have to do the same thing for this one. So L, M, N, O. And so when it asks me, hey, name the corresponding parts of this thing, it's just talking about the pieces that match up. And I didn't even actually need to draw these in order to do that. I could look up here and say, hey, H matches up with L, which is telling me then that the measure of H is the same as the measure of L. In other words, H and L are the congruent angles. Okay? Likewise, I and M are in the same spot, so I and M are congruent angles. And then J and N are in the same spot, so J is congruent to N. And then K and O, all right? And so, again, just looking at the name of this thing, I can match up all these pieces, or I could draw it and then start matching up the pieces, okay? That's in terms of the angles. Let's talk about the sides. I'm going to put those over to this side. But look at the sides, like HI. So that side is congruent. Well, the side that's in the same position is LM. And again, look at the names. If you come back up here to the top, you could say, hey, look at this, HI and LM. You can construct even the sides from the original name, okay? And so then we just kind of head through the rest of these. We would say, M. Well, I guess I should keep going with the one on the left first. IJ is going to be the same as MN. JK is going to be the same as NO, and then KH. And I'm just working my way around this thing. It's going to be the same as OL, okay? And again, I can look at that based on the picture, or I could take that right from the name of this thing, because even the name has things in the same position, okay? Looking at something like this guy, again, it's going to kind of become all about matching this thing up. But if triangle ABC is congruent to triangle DEF, I want to find the measure of angle D. Well, let's start with ABC. If I start with triangle ABC, there's a couple things that I know. One, I know the two angles that are already given, the 30 degrees and the 65 degrees. But then the second thing I know is that third angle. Because these add up to 180, I can say, hey, what I already have here in terms of the angles, these guys together, is a 95, which means my missing angle, that should be a subtraction sign, which means my missing angle has to be an 85 degree angle. So now I have this angle down here as well. So let me label that one. So I have angle A. Now it's a matter of matching these pieces up. Since these two triangles are congruent, A matches D and B matches E and C matches F, I just match the pieces, say, hey, these pieces match, and then lastly, these pieces match. And so if it's asking about angle D, well, angle D matches angle A, so angle D also has to be the 85 degrees, okay? So it's really just a matter of making sure you find the angles and then matching up the congruent angles. So the measure of angle D equals 85 degrees. And if I have the angle in one triangle that this thing is congruent to, I automatically have that angle. I just have to match it up, okay?